We are mapping and determining where critical fish habitat is in a particular area off the coast of North Carolina in what's known as a wind energy call area. It's an area that the government agency, the Bureau of Ocean Energy Management, or BOEM, has designated as a place where future wind energy development may occur. So it's a place where they would perhaps put turbines in the offshore environment.
The wind energy area that we've been working in is off of Wilmington, North Carolina. It's about 15 miles off of Cape Fear. It's one of 3 wind energy areas off of North Carolina. There's another one that is just west of Wilmington East called Wilmington West. And then there's a third area off of the northern Outer Banks that is called Kitty Hawk.
We are looking for habitat that is what we call hard bottom. These are areas that are either consolidated sediment or exposed outcroppings of rock. Sometimes they are man-made structures, such as historic shipwrecks, and these areas form important habitat for fish as well as critters that you'd sometimes see on coral reefs, so invertebrates and macroalgae. Some of them are these incredible ledge features that are up to 30 feet or 10 meters tall. Other ones are kind of like a parking lot. They're flat and don't have much relief. Hard-bottom sites are critical habitat for fish because they function as places where the fish can forage, they can seek refuge from predators in the nooks and crannies in these habitats. They're also something that we call near-shore connectivity corridors, where fish can move from areas in the estuaries to offshore reefs using these as stepping stones.
I think people would be amazed at the types of habitats we have offshore of North Carolina. They vary from the tropical reefs, or what seem like tropical reefs, to vast tracts of sand that don't appear to host any biological life whatsoever, what we might call an ocean desert. What impresses us greatly when working offshore of North Carolina are the diversity of fishes that occupy the hard-bottom habitats. Those are the ones that we think might be some of the more sensitive habitats offshore. And we have very little understanding of where those habitats are located. Fishermen know where they are. They fish those areas all the time, and we've been learning a great deal from the fishermen on where these habitats are located. That gives us a bit of information on where they are, but we still have a limited understanding of how these habitats are structured offshore. Are they clustered in one area, or are they randomly distributed across the entire coastline of North Carolina? We have a pretty good understanding of how these hard-bottom habitats support the fish that are important to our economy and ecology. If BOEM is interested in reducing the potential environmental impacts from, say, developing a wind farm off our coast, we wish to conduct some studies to point them to where these habitats might occur, where these most sensitive areas might occur, so that those areas could be avoided in terms of development and potential environmental impact. What it comes down to is that we would love to get eyes in the water everywhere that we go offshore of North Carolina, and in 277,000 acres that would just be physically impossible. So we must use remote sensing tools to give us an image of what the seafloor looks like. 2 of the ways that we did that in the early stages of this project were using side-scan sonar and multi-beam sonar. Side-scan sonar gives us about a 300-meter swath or a 1,000-foot swath of the seafloor that shows us the texture of the seafloor. How hard is the seafloor? It can show us different types of sediment or give us an indication of the type of sediment that are on the seafloor. The multi-beam sonar, on the other hand, gives us an image in the topography or the relief of the seafloor. It gives us the elevation, like you would see on a Google Earth map. We put those pieces together, and it gives us both the texture, the hardness and roughness, and then the elevation of the seafloor, and that gives us an indication of the types of habitats that might occur. We then use divers to validate and ground truth what the sonar is telling us. The imagery that we're gathering using the sonar and from our divers are putting together a really interesting picture of what these habitats look like from a digital sense, and then helping us interpret from a biological sense using our eyes what those habitats are really like.
One of the things that we do while underwater on our diving surveys is count the fish. And we set out this 30-meter long transect tape. It's basically an underwater measuring tape. And we swim along that tape and count the fish that we see. We record what species they are, we estimate their length, and we can use that information to identify which habitats are the most important fish habitat. In coral reef systems, it's well known that when you have a more structurally complex habitat, the fish diversity, the abundance or the number of fish will increase. But nobody knows if that relationship is the same here off the coast of North Carolina. And if we can understand whether these complex habitats may be better fish habitat, we can use that to identify which areas are most critical to conserve and protect in the long run. Hardbottoms are really important for the residents of North Carolina because they support so many fish that we depend on, both for recreational and commercial fisheries. They also support a vibrant recreational diving community and tourism. And overall, they're really important for the health of our ecosystems because they provide nursery habitat, places where fish can eat or forage, places where they can refuge, and also corridors to help them move from inshore to offshore locations. And so because they perform all of these functions, they're really important for us to conserve and protect.